over 2, right? You have n over 2, okay? So then this is equal to mu x, right? This is equal to mu x. What about the second one? The same thing, right? Because the number of size is the same thing, is mu x, okay? I mean, n over 2 is the size, okay? The sample has n over 2. And basically, you follow the same kind of operation, what you get? You're going to get the same thing. So in terms of unbiased, okay, in terms of unbiased, these two estimators are both unbiased, okay? They are both unbiased. So in terms of unbiased, they are equally good, okay? They are equally good. And then we have to check which one is more efficient, right? If we're going to check efficiency, what you're going to get? You have to check the variance, right? You have to get variance. Okay, any question on this part? Any questions on this part? Okay, so far so good? Okay. Here, you know, if you're going to try the second one, basically what you're going to get is the same thing. The only difference is, okay, this is going to be n over 2 plus 1. Okay, this is going to be n over 2 plus 2. And what about the last one? The last one will be xn, right? Okay, so, you know, the operation, the calculation is basically the same. I don't want to do this again. Questions? Okay, let us try variance. Okay, let's try variance. So for variance, you have variance mu 1, okay? And then you have variance 1 over n over 2, summation xi I is equal to 1 to n over 2. Okay? So you have, okay, if we're going to move this out, what are we going to get? Mr. Chen, if we're going to move this out, what should be the number here? Right. So it is here n over 2 square, right? And that is n square over 4, right? Okay. And then you have v x1, x2, etc. plus x n over 2. Okay? Questions? Okay, so from here, what you're going to get? What you're going to get? You're going to get 1 over n squared over 4. Here you have sigma x squared, etc., sigma x squared, right? Generally, we assume, you know, all these samples are drawn independently, okay? Generally, it is assumed all these samples are drawn independently. So the correlation, the covariance part, okay, the correlation coefficient is equal to 0. So the covariance is equal to 0. So this is what we get. And how many do we have? N over 2, right? So then it is equal to n over 2 times sigma x squared. Okay? And basically, for this part, for the second one, okay, mu 2, you're going to get the same thing. For mu 2, you're going to get the same thing. Okay? The only difference is, here you're going to start from n over 2, okay, plus 1, okay, n over 2 plus 1, and 2 n, right? Okay, to n. And here is mu 2, okay? So basically, if you're going to do the same thing on the second part, mu 2, everything will be the same. The only difference is here, okay? Of course, it is going to be different, okay? Here you would have n over 2 plus 1, okay, n over 2 plus 2, okay, x, n over 2 plus 1, x, n over 2 plus 2, and here you have xn. The other things are all the same. So if you're going to say mu 1 and mu 2, they are both unbiased, and which one is better? both are equally good. Okay, both are equally good. Questions? Let us try to get the second one. Any questions? Okay, let us try the second one. The second one say, a manufacturer manufacture tiles. Okay, they make tiles. And of course, for every product, you offer guarantee. Okay, what means guarantee? So suppose you have 1 year guarantee, and suppose the CD player, okay, it breaks down before 1 year, and they take it to your shop. What you gonna do? You have to either repair for this person or replace it. Okay, give him a new one. Okay, or repair it. If you repair it, you have to pay labor or materials. And if you replace it, okay, that's even more expensive, right? You have to give him a new one. So in this case, guarantee is an expense to the company. Okay, so generally, when the company want to offer guarantee, they have to estimate what is the cost. Okay, if you have taken accounting, then you should know this, because sometimes you have to take reservation or amortization for all these costs. Okay, so here what you read. So this is the duration, okay, how long the tile can run. It can run for 56,000 miles, okay? And here is the variance. Variance is 2,000 square, so that is like 4 million, okay, 4 million. And so the company would like to set up a guarantee so that no more than 4% of the tiles will have to be replaced. What does that mean? Of course, first you have to be able to draw this diagram. Okay? So this is a normal distribution, right? And you want to make sure that the replacement is only 4% of the tiles. Okay? So is it here or is it here? So which part? If you say this part, what does that mean? That means you have to replace 96% of the tiles, right? So usually you're going to assume 4% of them is bad, but 96% of them should be good. Okay, so the 96% should be here. You only want to make sure that, here, this is 66,000, right? So that means this is the mean. On average, the tile can last 66,000 miles. But on this side, right? On the right-hand side, it is larger than this, right? If it is larger than this, it is good, right? It is only when some of the tiles may not last long enough, right? They run out, okay, by wear and tear much earlier. So that is on this side, okay? That's on this side. So in that case, what you gonna do? So here you have to check the table. So here is 4%, right? So you have to check the table. So if here is 4%, how much is here? If here is 4%, how much is here? Mr. Ren, how much should be here? 46%, right? So then you have to find a corresponding number. So from the table, okay, from the table you can get a Z. From a table you can get a Z, okay? Anyone got a table or a book? No? Okay. Anyway, you can get a table and to find out what's the corresponding Z. The corresponding Z, okay, is actually negative 1.75, okay? So then, here you get the corresponding Z, but this is not the answer, right? The answer is how many miles is here, okay? So in terms of that, because you want to get Z, right? And Z is equal to negative 1.75, okay? This is what you get from the table. So what does that mean? That means from 0 to 1.75 is equal to 46%, okay, is equal to 46%. And then, how to get the corresponding X? So here you are given Z, and you are required to find the corresponding x. Okay, so what is z? Z is x minus mu x, right? How much is mu x? 66,000. And how much is sigma x? 2,000, right? And that is equal to negative 1.75. And so x is equal to 66,000 minus, okay, 1.75 times 2,000. So then what you get? You get it is 62,500. So here, in terms of z, is equal to negative 1.75, and in terms of the miles, 62,500. Okay? So usually you are required to get z, and now you are given z trying to find a corresponding x. Okay? And sometimes the equation may be even more difficult. We give you two equations, two conditions, and from these two conditions you can get two equations, and then you can get, you know, the x and sigma x. But in this case, we only require you to find out one number. Sometimes we may ask you to get two numbers. Then in that case, you have to use two equations, two unknowns. Okay. Sometimes you will be required to do that. Okay. Question. Any questions? Let's get to this one, okay? Let's get to question 4. Can I erase it? Okay. So only 50% of the Taiwanese, okay, wear seatbelt when driving, okay? So when you drive, you should wear seatbelt, right? But sometimes people don't. And let us say only 50% of the people in Taiwan wear seatbelt when driving. And now how many samples do we get? We get 50, right? So we get 50 persons, okay? And what is the probability that exactly 5 persons wear seatbelt? The lady there in pink, Miss Wang. So the first question. What is the probability that exactly 5 persons wearing seatbelt? What kind of distribution is this? What kind of distribution is this? What kind of distribution? Binomial, right? Binomial distribution. Okay, so P, you want to turn the words, okay, you want to turn the words into formula, right? Px is equal to 5, right? So what is here, Miss Wang? Okay, Mr. Wu. You have 50 people, right? You choose 50 persons, right? And how many? X. But here we already know how many? 5, right? So from these 50 drivers, you take 5. And what's the probability this one will be wearing seatbelt? 0.5, right? To how many? To 5, right? And here 0.5 to 45, okay? You know, if you cannot do this kind of problem now, you will be in trouble when you get to the second midterm. Okay, I'm serious. Okay. What about the second one? So this is for the first answer, right? For the second one, it is more than 7, okay? So that is probability X greater than 7, okay? If it is greater than 7, does it include 7? No. More than means greater than, okay? More than means greater than, okay? So then you have summation X from how many? From 8, right? Because greater than 7 must be 8, 9, 10, etc. to 50, right? And so it is 50. What should be here? X. And then 0.5 to x power 0.5 to 50 minus x power. Okay? Questions? Okay, the last question is about the mean and the variance. So the gentleman behind Mr. Wu, so what should be here for the third question? For the third question? It is a binomial distribution, right? It is a binomial distribution. So what is the mean and the variance? Okay. You shouldn't have shaken your hands before I pointed you. Okay, here. The mean and variance for binomial distribution. Do you remember the formula? Hey, I think you're going to be in trouble. It is equal to n, p, and what about here? N, p, q, right? It is not difficult. So what should be here? Okay, the lady there, okay, in brown coat. $50 times 0.5, right? So what you get? You get 25. And what about the next one here? Okay, 50 times 0.5 times 0.5, 12, sorry. Yeah, it's 12.5, right? Okay, questions? Okay, so we are done with this. Now let us try this one. Okay, here you have an elevator. Okay, this elevator can take 15 persons or 750 kgs. Okay, but sometimes it may. So, just for example, if you get in an elevator, there are already a whole bunch of people, a lot of people, right? So maybe let us say the elevator say we can take 10 persons. But sometimes there may be 12, maybe 13, but does it ring? No, it doesn't. Why? Because not every person is that heavy, right? So sometimes people are more heavy than, some people are more heavy than the normal, okay? So even though you got 12 people, 13 people, sometimes it's still fine. Okay, what does that mean? That means, you get some of the people, right? Even the average is 75, and the variance is equal to 10 squared, that is 100, right? So even this is the mean, and that is the variance, but sometimes you get people on, so here you have 75, okay? That is the mean, okay? So sometimes you get a lot of people on this side, so then you will more get the warning bell more frequently. But what about if you get people from this side? You will get less warning, okay? So then, what's going on here? Let us try to find out. Here you have 15 persons, right? You have 15 persons taking this elevator, right? 15 people. So what does that mean? It is a sample sum distribution. Okay, it is sample sum. Okay. What about the other one? The other one is sample mean. Okay. But here we are talking about sample sum. So for each one, okay, you have 75, 100, right? Now you have 15 people. Then what should be the number here? You have 15 people. What should be the number here? You have 15 people. What should be the number here? 750, right? 750. What about here? Sorry, it should be 15 times 75. Okay, how much is that? Can anyone get a number for me? 75 times 15. How much? 1125? Okay, then this one should be easy, right? 1500, okay? Okay, and now we have to turn this question, right? The question is, we have an elevator, and how many it can handle? Only 750 kgs, okay? So then you are trying to find out probability S greater than or equal to 750, okay? Because if you get 750, the elevator will stop, right? It cannot take anyone because it's overweight, okay? So here then, the same thing, you're going to turn S into Z, right? Turn S into Z. So you have, Z, okay, greater than or equal to 750 minus how much? Mr. Fu, what should be here? X bar mu, right? 1125. And what about here? What about in the bottom? Are you sure? Square root 1500, right? So from here you can get a corresponding Z from the table, and then you can get a probability, okay? Any questions? And the probability is almost 1, okay? The probability is almost 1. Anyway, questions? Questions? Okay, let's take a little break. Animals joining a race. So it is rabbit and turtle. So we know that turtle runs much slower than rabbit, right? And so here the race is that turtle starts 30 minutes earlier, okay, than rabbit, okay? So what's the probability for rabbit to catch up with turtle? So that means you have a distribution. So let us say this is X, okay? For rabbit, it is X, normal distribution. The finishing time, 50 minutes. The variance, 200 minutes. And then you have Y, okay, but the turtle, you have finishing time, 70, and the variance is 20. So you know that actually rabbit is much faster than turtle. But you know, the difference is only 20 minutes. Okay, the difference is only 20 minutes. And here, the turtle runs, okay, starts earlier than rabbit by 30 minutes. So in this case, what's the probability that rabbit going to catch up with turtle? So here is the question. So you have X and Y. So in this case, what does that mean? That means this must be faster, okay? How much faster? More than 30 minutes faster, so that rabbit can catch up with turtle, okay? So you have to run much faster. So the time, the difference between them, okay, the time difference must be greater than 30. So actually what this question actually is that, what is the probability, okay, for X minus Y, okay, greater than 30? Or, what should that be? Actually, it should be less than 30, okay? Because, you know, actually, you know, if you look at this, okay, if you look at this, I don't want to get things too complicated. You know, in terms of speed, okay, in terms of speed, it's easy, right? In terms of speed. In terms of speed, it is, rabbit must be faster than turtle, okay, in terms of speed. What is speed? Speed, okay? But in terms of time, it must be less than that, okay? So actually, it is Y minus X greater than 30, right? It must mean that turtle spend more than 30 minutes, okay? It is in terms of time. This one must be shorter. Okay, in terms of time, this must be shorter and this must be longer. Okay, but in terms of speed, which one is faster? Rapid. Okay, so what does that mean? That means px minus y less than negative 30. Okay, in either way, that is the same. Okay, even if we use the equation, use the formula before, it is you look at the right hand side, but actually what you are looking at is okay, before it is looking at the other side, but here it should be this side. Okay, it should be this side. Okay. Of course, if we use x or y, that is easy, right? Because you deal with only the distribution of x or y. But now you are dealing with x and y simultaneously. Okay. So then you have to know what is the. So you know that the distribution of x and the distribution of y. But what is the distribution of x minus y? What is the distribution of x minus y? So then you are trying to deal with this, right? So expectation of x minus y. What is that equal to? Mu x minus mu y, right? What is the variance of x minus y? Remember, if you have this, it should be Vx plus Vy minus 2AB. Sorry, because AB is equal to 1, right? So it should be 2 covariance xy. Remember this formula. W is equal to AX plus minus dy, right? If it is expectation of W, what is that? A mu x plus minus b mu y, right? If it is variance of W, what you get? A square Vx plus b square Vy plus minus 2AB covariance xy. Okay? This is what we already talked about before, right? Remember this? Okay, so you always have to utilize what you have learned and to solve the problem. Okay, so here, x and y, okay, x minus y, what is that? It is x minus y, here you have mu x minus mu y, and what is here? Sigma x squared plus sigma y squared. Right? Questions? Any questions so far? Okay. Okay, then what does that mean? Because here we already know the question. The question is here, okay? The question is here, and how to solve this question. Okay? Can I erase this now? No. So because we are dealing with two distributions, so you have to find out what's the distribution of x minus y. Okay, and it is here. Okay, questions? Can I erase the second one here, the variance? Miss Wang, yes? Thank you. Any other? Okay. And so, if you know the distribution, that should be easy, right? So here, what is it? So n mu x minus mu y is equal to negative 20, right? What about here? What about here? Here it is equal to 220, right? Because generally, of course, you're gonna know the running time for rabbit and turtle, it should be independent, right? So the covariance is equal to 0. Okay, the covariance is equal to 0. Sometimes it is not. Okay, sometimes it is not, depending on the situation. But in this case, they are independent, so the covariance is equal to 0. Okay, and so the question will be easy. So when you are looking for probability, okay, x minus y less than negative 30, right? So you have probability, okay, z less than negative 30 minus negative 20, right? And then divided by square root 220. And of course, in this case, you can get z, right? You can get z, and then you can solve for it. Okay? Questions? Any questions? So when you get to the test, we will give you the normal distribution table, and also you need to bring calculator. And be careful when you do the calculation. Okay, sometimes, for example, I remember for the first midterm, the answer is 2.4785. Suppose it's like this. Some people just put 2. Okay, if you do this again, you won't get any credit. Okay, if you do this again, you don't get anything. Okay, you have to put down, because really, it doesn't cost anything to you, right? Because if you punch the number into your calculator, you get everything. So there's no reason you should give me something like this. Okay, you have to give me the whole number there. Okay. Okay, questions? Okay. So from here, then you can get, what's the probability, right? Here you can get corresponding z, and then you can get a number. Okay, the probability. Okay, questions? Okay, can I erase this now? Okay. Maybe I should erase this part. Okay, let us get to this question, okay? So there are 400 persons in a department, okay? And the average is 70, okay? And the variance is equal to 4. So how many people score between 67 and 83, right? So what are you looking at? You are looking at for the probability x, okay? Greater than 67, less than 83, okay? In this case, does it tell us what kind of distribution it is? Does it tell us what kind of distribution it is? No, it doesn't. So what should we use? We should use Chebyshev inequality, right? Okay, so let us try. So in this case, you have P, okay, x minus mu x, right? Minus mu x. How much is mu x? 75, right? 75. So 83 minus 75, you get 8. And here you minus 75, you get negative 8. Okay? Questions? So you just follow the formula. Then you have P negative 8. So it is x minus mu x absolute value, right? Less than or equal to, so let's put equal here, 8. And here it is equal to, the variance is equal to 4, right? The variance is equal to 4. So how much is the standard deviation? 2. Okay, so it is 4 times 2, right? So that means Px minus 75 less than or equal to 4 times 2 greater than or equal to 1 minus 1 over 4 squared. So that is 15 over 16. Okay? Let me erase here. Okay. So that's the answer. Okay? There's time we talk about it, right? How much should be k? K at least has to be greater than 1, right? K has to be greater than 1. If k is less than 1, you don't get anything. Okay? Questions? Questions? Okay, let's get to this one. So the sleeping time, okay, the length of sleep is a normal distribution. The average is 7.8 hours, and the standard deviation is 1.6, so the variance is 1.6 squared. Napoleon sleeps less than 3 hours, okay, so we know that Napoleon doesn't need to sleep very much. Okay, so the sleeping time is only 3 hours. The length of his sleep 3 hours. So what is the proportion of people like Napoleon? Okay, so you are looking at this distribution. Okay, the sleeping time. Okay, here it is 7.8, right? So where is 3 hours? 3 hours is on this side, right? So some people sleep less than 3 hours. Okay? Some people sleep less than 3 hours. So you are required to find out what is the proportion of people like Napoleon. So what does that mean? You have this kind of people sleeping less than 3 hours. Okay? And so you want to get random sampling to get one. What's the probability that this one will sleep less than 3 hours? So actually you are going to get the probability, okay, of the people sleeping less than 3 hours. So what you need to get? You need to get how much is here. Okay, so P, okay, you have X less than 3, right? And so in terms of Z, P Z less than 3 minus 7.8 divided by 1.6. Because this is the standard deviation, right? The variance is 1.6 squared. So this is what you get. You get a corresponding Z, and you can get a probability, right? You can get a probability. Okay? If you check the table, corresponding Z, then you can get a probability, and that is the answer. Okay, that is the answer. Questions? Any questions? Okay, let's try the last one. The last one is here. Okay. So here you have a distribution of a score of statistics is normal distribution, 85 phi square. Okay? So if the top 5% will get A, if the top 5% will get A, what is the minimum score will get A? What means the top 5%? So here you have a distribution, right? So you have 85 here, okay? Of course, the higher, the better, right? And only the higher, those score higher will get A. Those score lower will get B, C, etc. If it given, if you score too low, what you're gonna get? You're gonna get flunk. Flunk means fail in this class. Okay. So the top 5% will be here. Okay. From here you can get a corresponding Z, right? If you check the table, you can find a corresponding Z. And so what you need to get? You need to get a X. Okay, you need to get an X. So here you need to find a corresponding X. So what does that mean? X minus Z, okay, divided by sigma X must be equal to, if it is 5%, what should be here? 1.64. Okay, if it is 5%, it should be 1.64. If it is 2.5%, so let us say, if it is 2.5%, what should that be? That would be 1.96. Okay, I told you a table, right? I told you a table you need to memorize. What about 99? Suppose, here it is 0.05. So if it is 5%, okay, it is 1.64. If it is 2.5%, it is 1.96. What about here? So that is equal to 0.5%. 2.54. I believe that should be 2.54. So some of the numbers should be, memorized. Okay, some of the numbers should be memorized. Okay. Now we just plug in the number. The number is, it should be, here, there's a mistake here. It should be mu x. Okay? So x minus 85 okay, divided by 5 must be equal to 1.64. Okay, so that means if you want to get A, at least you have to get this much. So X is equal to 85 plus, okay? Right? Okay, is it 8.2? Can anyone verify this? Anyone got a calculator? Is it 8.2? Okay, so the total is 93.2. Okay, so you got it. Okay? What about here? If you don't want to fail in this class, okay, if you don't want to fail in this course, okay, you don't want to take it again, the bottom 25%, so it should be here, bottom 25%, right? And we already know, if it is 2.5%, you use 1.96, right? But this is on the left-hand side, so it is negative, okay? So here, if you don't want to fail in this class, okay, then X minus 85 divided by 5 is equal to negative 1.96. Okay, so 85 minus, is that right? Okay, and so what does that mean? How much should that be? 0.2575.2. Okay, is that right? Okay, so generally this, these questions are very typical. Okay, these questions are very typical, and it may be in your second midterm. Let us take a break. This is on some of the problem sets, and now we're going to get to interval estimation. Okay, and of course we have point estimation. Point estimation means, okay, you get a value. But as we have talked about this before, sometimes that value may happen, it may not. And there's no way to tell whether it's going to happen or not. So generally, very few people deal with the point estimation. Oftentimes what we do is interval estimation. As a matter of fact, if you check the financial news of daily newspaper, you're going to see a lot of people have done a lot of estimation. Say, Thai plastic, okay, Thai plastic, the price range, or the Zhanghua Bank, okay, what's the price range? Oftentimes you may have read something like this, okay. So the reason that a lot of people do this is because from statistics we know there is a probability that this will happen, okay? And so you know that how accurate, okay, how accurate this number may be. So for example, let us try this, okay? So first thing we have, so for example, P, okay, minus 2, okay, negative 2, less than equal to Z, less than equal to 2. What is the probability? The probability is 0.954, okay? And now we're going to try to manipulate this formula. In this case, we are talking about sample mean, okay? If you are talking about sample mean, so you know that X is has a mean of mu x, variance sigma x squared. What about x bar? What is this? Here, mu x, right? What about here? Sigma x squared over n. Okay, good. So this is z, right? So let us turn z into that formula there. So you have P negative 2 less than equal to x bar minus mu x square root sigma x squared over n less than equal to 2. Okay? Any question to this point? We're going to forget about this part because it is always the same, okay? We are trying to figure out what's going on here. So now you have P, okay, negative 2 sigma x squared over n x bar minus mu x, okay, less than or equal to 2 times n sigma x squared. We just do a very simple multiplication. Each side multiplied by this. Okay, so then we have this. Okay, questions? And now we turn this around. Okay, so let us say it is 3 less than or equal to 4 less than or equal to 5, right? But I want to turn x bar minus mu x, okay, x bar minus mu x into mu x minus x bar. What does that mean? That means I time it by negative 1, right? Okay, it's multiplied by negative 1. So if you multiply this by negative 1, it means negative 4 greater than or equal to negative 5 greater than or equal, negative 3. Because this is inequality, right? This is inequality, less than or equal to, less than or equal to. Okay? If you time it by a negative number, here you multiply it by negative 1. Okay, negative 1, negative 1. What do you get? You have to turn this around, right? Okay, you have to turn this to the other side, the same thing. Okay? So you have 3 less than or equal to 4, less than or equal to 5. If you multiply each by negative 1, what do you get? Here, it has to be greater than this one, that one. Okay? Okay, so then we will multiply each one by negative 1. So you have here, because you multiply by negative 1, it becomes positive, right? And you have sigma x squared over n greater than or equal to mu x minus x bar, right? Less than, greater than or equal to negative 2, okay, and sigma x squared, okay. Questions? Okay, then from here, what you're gonna get. But as you can see, here is positive 2, negative 2, positive 2, negative 2 actually is the same on the other, on the both ends, okay? So then you have P, okay, negative 2 sigma x squared over n less than equal to mu x minus x bar less than equal to 2, okay, and sigma x squared. Okay? Questions? Okay, then what do you get? You get P here, x bar minus 2, okay, sigma x squared divided by n mu x, x bar minus, plus. And here, of course, the probability is equal to 0.945. Okay, what does this mean? Originally, this is what we know, right? For z between negative 2 and 2, the probability is equal to 0.945. But now we manipulate this equation, okay, and this part, and then finally we get P, okay, x bar minus 2 square root sigma square over n less than or equal to mu x less than or equal to x bar plus 2 times square root sigma square over n is equal to 0.945. What does that mean? That means mu x, okay, for mu x to fall between this number and this number, what is the probability? The probability is equal to 0.945. So this is what we call confidence interval. Okay, this is what we call confidence interval That means if you're going to estimate mu x, okay, if you want to know what is the possible value of mu x, it is here or here, between this number and this number. And how accurate it's going to be. How accurate is this estimation? That means the true value between these two numbers, what is the probability? The probability is 0.945. So what's the correct probability? 0.945. Is it possible that you made mistake? Yes, you may make mistake, but what's the probability that you made a mistake? 0.046. Okay, so here, this kind of interval is what we call confidence interval, okay, with what percentage? 0.945. So it is 95.4% confidence interval. So when you mention 95.4 confidence interval, what does that mean? That means with 95.4, this probability, you're going to get it right, okay? This is a very specific, we use 2, right? But as we say, generally you're going to use confidence interval. Confidence interval is going to be 1 minus alpha. And the other one is significant level. Significant level. And what is that? Alpha. So the confidence interval is 1 minus alpha, and the significant level is alpha. Okay? And what to deal with it? So generally, first, let us talk about two-sided interval estimation. Interval estimation. If it is two-sided, that means it is the lower bound. Here it is called lower bound, and here it is called upper bound. Okay, for lower bound, of course, it is the highest possible value. The higher bound is the upper bound. We call upper bound. UPPER, upper bound, and here it is the lower bound. Okay, upper bound means the possible highest number here. And lower bound is the lowest possible value here, okay? So generally, the mu x. So for example, we say, if you're going to estimate the stock price, okay? If you're going to estimate stock price, what is the possible value here? It may be here or here, and in between. So here, this is the true value, okay? This is the true value. It may fall between this one and this one. But generally, we're going to say you have confidence interval. Okay, confidence interval, it is this part. It is 1 minus alpha. Okay, 1 minus alpha. And what about here? Because you have 1 minus alpha here, and this one, okay, this part plus this part should be equal to alpha, right? But then you have two sides, and this should be symmetric. Okay, so here you have alpha over 2, and the same thing here, you have alpha over 2. Okay, and this value, okay, in this case we are talking about normal distribution. Okay, in this case we are talking about normal distribution. This is denoted as Z alpha over 2. Okay, and also this is Z alpha over 2, but it is negative, right? It is negative. So here you have here and here. So here we use a specific value. A specific value that is equal to 0.954. But generally, what is here? This is going to be 1 minus alpha. Okay? So I'm going to write down a more general form. So this is something very specific. We say it's between 2 and negative 2. So the confidence level is 0.954. But sometimes you may use 95%, okay, 99%. So we don't necessarily use a very specific number. So we use a very general notation. Say confidence level, it is 1 minus alpha, okay? And significant level, it is alpha. Sometimes we also use level, okay? Level. When you say confidence interval, you are talking about this, okay? From here to here, that is confidence interval. But if you talk about confidence level, that is 1 minus alpha, okay? Okay, I am going to write down something more general here, and let us take a look. Okay. So when you have P, okay, negative Z alpha over 2 less than or equal to Z less than or equal to Z alpha over 2, then you get that is 1 minus alpha, okay, 1 minus alpha. So in terms of the question, if you are asked to calculate the interval estimation, that should be very simple, okay? So then from here, okay, from here what you get? You get P x bar minus Z alpha over 2, okay, sigma x squared divided by n less than or equal to mu x, okay, less than or equal to x bar plus Z alpha over 2 sigma x squared divided by n, and here is 1 minus alpha. Okay? So basically, you know, if you're going to compare, originally what we have is x bar minus 2 times n sigma x squared less than equal to mu x less than equal to x bar plus 2 sigma x squared over n. Because for the question we talk about, you know exactly how much confidence interval you are looking at, right? 0.954. Because you are looking at 0.954 confidence level, so necessarily the Z alpha over 2 is equal to 2, right? So let us say if you're going to get here 0.95, right? If you're going to get a 95% confidence level, how much it should be here? If you're going to get a 95% confidence level, how much should be here? The girl in pink coat, how much should be here if we have 95%? It should be 1.96, right? If it is 0.95, it is 1.96. Then, let us say if you're going to get a 90% confidence interval, how much it should be here? 1.64, right? Remember I say, okay, if here it is 5%, it is 5%. If it is 5%, 5% here, what's here? Here it is 90%, right? So how much it should be here? 1.64, right? And if it is here, 2.5, here, 2.5, it should be what? 1.96 negative. Here it is 1.96 positive, right? Okay. Got to be very careful. I suspect that you haven't done enough practices, okay? This is very important. If you want to learn statistics well, you need to do your homework and practice, okay? So this is something very general, okay? And here is something specific. So in the question, I may ask you 10% significant level, 5% significant level, or even 1% significant level, okay? Okay, this is two-sided, okay? This is two-sided. But let us talk about one-sided. Okay, let me erase this part here. Okay, let us talk about one-sided. One-sided is simple here. So let us say here, then that is x bar plus z alpha, okay, times sigma x squared over n. So if here is 5%, how much should be the corresponding z? If it is 5% and it is one-sided, okay, if it is 5% and it is one-sided, what should be the corresponding z? What should be here? Here we say if it is 5%, what you get? 1.64, right? If it is 2.5%, it is 1.96. So can you tell me if it is 5% here, what should be the number? 1.64 or 1.96? The girl next to the girl with pink coat. So what should be here? 1.64 or 1.96? 1.64 exactly, because here it is two-sided, right? But here it is one-sided. So that means if it is 5% here, there must be a 5% there, right? So actually the number you should use is 1.64. It is not 1.96, okay? Because it is one-sided, okay, one-sided. Okay, any questions? Okay, so here we talk about point estimation, but now we are going to discuss something a little bit more complicated because we are talking about this one, okay, the difference okay. So it is good that we have talked about one example, right? The example is the race, okay, the race between a rabbit and a turtle. Okay, here we are going to talk about the difference between mu x and mu y. Okay, so for example, you have two machines. Okay, so let us say you have two machines, and of course you want to know whether these two machines are the same or not, right? So if they are the same, that means the production has no problem, because for the product from this machine or the other, the quality will be the same. Okay? But sometimes it is not. So you have to try to test it. Of course, later on we're going to talk about hypothesis test. But at this point, we only talk about interval estimation. So in this case, you have two machines, and you want to know what's the difference. So for example, actually you have x, and this is mu x, sigma x squared, sigma x squared, and you have y, mu y, sigma y squared. And you want to know what's the difference between x minus y, okay? Of course, you won't be able to get x minus y. What you get what you get is only the sample. So you go get x bar minus y bar, right? The sample mean distribution. So what is the sample mean distribution? So let us try x minus y, okay? For x minus y, what is the distribution? We just talked about it, right? The lady there. So what is the distribution? If you have x like this and y like this, what is the distribution of x minus y? Okay? Mu x minus mu y. And what about here? The variance. Suppose they are independent. Okay, sigma x squared plus sigma y squared. Okay, very good. So let us try one more. What about x bar minus y bar? X bar minus y bar. It should be the same here, right? Mu x minus mu y. What about here? The variance part. So here you may be a little bit confused because we have sample from x and sample from y. And the sample size may be different. Okay, the sample size may be different. So we have sigma x squared divided by nx plus sigma y squared divided by ny. What does that mean? If you put n here and n here, that means the sample size must be the same, right? For both x and y, but actually it doesn't have to. Okay, so here is the, here it should be x, right? If you have x bar, then you know the distribution is mu x, sigma x over n, right? But now we have two different distributions, x and y, and we don't know whether the size, okay, the sample size of x or y, whether they are equal or not. So in this case, we put nx here, and here we'll put ny here. It means they don't have to be the same. Okay, and now we have to turn to estimation. Okay, the same thing we need to turn to estimation. So what would be the estimation? So if you are going to estimate mu x, okay, with the confidence level 1 minus alpha and the significant level alpha, then you have mu x less than or equal to x bar plus z alpha over 2 times sigma x squared divided by n. Here, x bar minus z alpha over 2 sigma x squared divided by n. But now you are going to estimate mu x minus mu y, right? As a matter of fact, we can prove it again, but I don't want to go through this kind of tedious process. We don't have enough time. So what you guess? You guess that if you're going to estimate mu x minus mu y, it is x bar minus y bar plus z alpha over 2. So here it is the same, right? And now you have x bar minus y bar. What about here? What about here? It is sigma x squared divided by nx plus sigma y squared divided by ny. Okay, and x bar minus y bar minus z alpha over 2 nx sigma x squared sigma y squared and y. Okay, so here is the way to estimate the difference between two population mean. Okay, the difference between two population mean. Okay, any questions? Any question? Of course, in this case, what do we assume? We assume x and y are independent. Okay, in this case, we assume x and y are independent. Okay. Okay, let us get to another one. Let us take a break. Let us take a break.